Day 5 of the AICTE Atal Faculty Development Program at Mufakamja College of Engineering and Technology began with an industrial visit to T-Hub Hyderabad, one of India's largest innovation and startup ecosystems. During the visit, participants explored T-Hub's world-class innovation facilities, interacted with experts, and gained valuable insights into startup incubation, entrepreneurship, emerging technologies, and the collaborative ecosystem that supports innovation. The visit also showcased how artificial intelligence is driving real-world solutions across various sectors, including healthcare, while encouraging innovation, research, and industry collaboration. The afternoon technical session was delivered by Mr. Jojo on the topic Large Language Models in Healthcare, Applications, Challenges, and Future Prospects. The session highlighted how large language models are transforming healthcare through clinical decision support, medical documentation, patient interaction, research, and medical education.
A very good afternoon to everyone. Myself Razia Begum from Computer Science and Engineering Department. It is my pleasure to introduce our esteemed speaker for today's session, Mr. Jojo. Mr. Jojo is an AI/ML faculty member at Intelligent X Learning Hub, an accomplished data scientist. He holds an MS in data science from Liverpool John Moores University and a PG diploma from IIIT Bangalore. Mr. Joel has made significant contributions in computer vision, natural language processing, and responsible AI. His research includes innovative work such as the Green Mile, focusing on reducing carbon emissions in AI training, and Edge of Tomorrow, which explores efficient AI models for climate forecasting. His publications have appeared in prestigious conferences including RAI, ICVGIP, and ICMLDE. Beyond research, he has mentored over 1,000 students through data-driven learning programs and is known for making complex AI concepts such as GANs and vision transformers easy to understand and practically relevant. His achievements include the Academic Star Award 2024 from IIIT Bangalore, along with several academic recognitions for excellence in teaching and research. We are truly honored to have you with us today. Mr. Jojo, the stage is all yours. Thank you.
Good afternoon. So I'm Jojo and very so thank you for the wonderful introduction. It's the first time I'm hearing such an illustrative introduction about myself in such an illustrative manner. So thank you for that. So let's come straight to our topic. So the topic of discussion today is something which combines generative AI, which is something that everybody is talking about today. And when we talk about the corporate world, each and every company wants to invest in Gen AI today. And agentic AI has now come as an addendum to generative AI. So agentic AI, in terms of simple explanation, is basically Gen AI LLMs or generative AI models, which has capability to execute tasks. Simple as that. That is what agentic AI is. So attached to this, there are a lot of problems which need addressing. That is not something which we discuss about in corporate, but when it comes to real-world implementation of Gen AI applications, especially LLMs, there are a lot of associated problems, like who is responsible? LLMs are giving us data, LLM is giving us outputs, LLM is giving us decisions today, but the sole question is, who is responsible for it? And the next thing, of course, this is one thing that I discussed in my research paper called Green Mile. There is a reason why, I don't know if this would be controversial, but to be frank, there is a reason why we have a lot of data centers coming to India today. The reason is because they are not getting a place to survive in the US and Europe. Because most of us might already know, where data centers come, one resource would be in high demand, water. Because data centers consume a lot of water, or even if they want to think in terms of dielectric fluid, still they would require H2O to basically do it. So wherever data center comes, there is a lot of water which is required to basically cool the whole system or infrastructure that is present. This is a problem that was faced in quite acute gravity by US during the California wildfires. They did not have water to extinguish the fires, thanks to all the data centers that were present there. So which is the reason why the US and Europe is not promoting any more data centers. So it is coming towards Asia and let's say African countries to a certain extent, but it's mostly coming towards Asia. So efficient AI is something that is going to come forward in discussions now. So I was discussing with one of my professors when I went for ICVGIP at IIT Mandi. So he was telling me today everybody is going on about increasing accuracy, like developing much better models which solve problems with much more power. But a day will come when this will become non-viable, because our resources are limited. And all these AI models, although they run as software, they use resources. So there is a reason why Bitcoin mining is regulated all over the world. Because GPUs running at that extent is going to cause a lot of harm to nature, which is something that we don't realize at a small scale. But when it comes worldwide, it is going to cause a problem that might be beyond imagination. So in my paper titled Green Mile, what I tried to explore was the carbon emission of models. So there we found that many problems which take a lot of energy and resources has simpler solutions. So in one of my experiments, I was doing a weather forecasting problem. So weather forecasting problem, as we know, is usually a time series problem, right? Going forward, we need to predict the next timestamp. So what if we convert this time series problem into a regression problem, where all the features which have been present till the date or till that moment of time are considered as all the independent features, and the specific value for the next timestamp is the dependent feature. So it can be converted into a regression problem. So there we can implement regression algorithms which are quite efficient compared to time series algorithms. If we have to do hierarchical forecasting and all, it consumes a lot of computation. But when it comes to regression, it requires lot less computation. So what I was able to find is, although CNNs are reputed at giving very high accuracy compared to regression models, ensembling methods or stacked regression, when used and combined in such a manner, that was a trial and error approach. But one architecture that we designed was able to give accuracy compared or comparative to CNNs. So when such a problem like weather forecasting, okay, we did it at a very small scale, agreed, but still when such things are possible, it is time we start thinking about it. So it is all these things that I plan to discuss today in this session. So one thing that I keep about my sessions is, I like to keep my sessions interactive. Because if I go on giving a lecture, it will be boring for me as well as you. So it's all, also this is afternoon time, we are after lunch, we have, we are in that drowsy mode right now. So it's better we have an interactive session, because otherwise we are all going off to sleep. So, coming to, yes. Sorry? Green Mile. Green Mile. That's actually in stages of publication right now. It's with ACM, so you'll not find it online right now. Okay. So, we are talking about a very, simple problem. Because today I hear rumors that radiology is going to be the first field which is going to be fully automated in medical sciences, which according to me is not as easy as it sounds. Because we have a fundamental question. So here in this PPT, we'll have a chest X-ray. So we use it for detecting pneumonia and various, we use it for detecting TB. We have many lung-related, symptoms that we can look at to detect diseases. So the focal point of this session will be that chest X-ray, and we will be exploring all these related concepts in relation to that. So we will be coming back to that X-ray every time we hit a roadblock. So that is how the session is going to go forward. So the fundamental question is, we know that AI is very capable today, right? Very capable. It is able to give us answers to such questions that even pioneers find it difficult to solve. So now let's say we have the JEE exam. So even if we give it to an IIT professor or a problem to an IIT professor to solve suddenly, it's not easy as it sounds, because there are a lot of concepts that need to be recalled. There is a lot of thinking that needs to go into it. No, professor can guarantee that he or she will be solving every problem, right? So, coming to that, if we take in AI or models like GPT 5.5, we have Claude Opus 4.8 now, we have Fable 5 now, which solves any problem that is present in the world today. That is what they say, at least, right? So it has become so capable. So now the machine is always right. But then comes the second part. Who is responsible for it? The machine is right, I agree. But who is responsible for it? So kindly keep this question hanging in your mind. We'll revisit this once we come to the end of the session. So what I intend to achieve by the end of this session is that we should be able to map the applications that are possible in healthcare using generative AI as well as discriminative AI. We should be able to understand the possibilities of failure, because deploying models in real time is different compared to testing it. When we test it in the lab, we take a test set, compare accuracy, let's say maybe go for precision recall, done and dusted. That's not what the deployment is. Once it comes to deployment, it's a different story, right? Why we should have governance when it comes to healthcare, at least. We'll be reasoning through that. We will be understanding radiology today, because people claim it is the first field which is going to be automated. Let's see. We will be working on the 4 pillars which generative AI has to actually work on. And we will be doing an activity which will actually establish what we were discussing on. So this is what I intend to achieve by this session today. So this is a brief outline of what I've planned. So first we will be discussing about the landscape, what all things are possible. Then we'll be discussing failure opportunities. Okay, after that we'll have a small break. Then we'll go to the 4 pillars that establish, or strengthen these AI models so that they don't fail. And in the end, we'll be talking about the future opportunities that are present here. Okay. So coming back to this question once again, the machine was right, or the machine is right, but who is responsible for it? So in the recent past, ICMR, which is the Indian Council for Medical Research, has posed a very interesting question. Let's say AI is diagnosing diseases now. AI is telling you have TB. AI is telling you are likely to develop a heart disease. But in the end, who is responsible for it? AI tells you you are going to die, and you die of a heart attack because of fear. Who is responsible for it? Will the model take responsibility? Because today, when it comes to medical negligence, the rules are pretty tough. Doctors are scared, to be very frank. I know doctors, I have doctors as friends. I'm sure that you guys will also have. They're scared to do things, because one mistake they make, they know people are going to sue them for life. That is how difficult those decisions are. So coming to AI, if AI makes a wrong decision, who is responsible for it? That's the billion-dollar question. So we are going to talk about a few intuitions or few misconceptions that we may have in mind, and we are going to try to break them today. Okay. So I hope everybody has got their phones with them. Everybody has phones, right? Okay. So, okay. Here we have an interesting question. So there were 6 medical case studies, unpublished cases. So it's nowhere available in the internet so that somebody can just rote learn, or even the AI can rote learn and give answers. It's unpublished. 6 unpublished case studies, and they were genuinely hard because it was rare cases. So when we talk in terms of statistics, when we talk about any distribution or any sort of data, we usually assume that it is a what sort of curve? Any data that is present in the world, what sort of curve is it usually like to be? Any idea? Are you able to recollect? It's usually a Gaussian curve, right? Or a bell curve. It's always a normal distribution. If we talk about any sort of population that is present in the world today, or any sort of data with respect to population, it is most likely to be a normal curve, right? So when it comes towards the tails, that is where things get difficult, where the standard deviation is high. So these cases were from the tail. So that it becomes rare, it becomes difficult. And what they did in this experiment, so this experiment was done, just give me a sec. So this experiment was done by the JAMA journal, so which is a reputed journal in healthcare. So was it JAWA or JAMA? I got a bit confused right now. So it's a very reputed journal in healthcare. So this study was done by them, the JAMA Open Network Research Journal. So it publishes very prominent research narratives when it comes to healthcare. So they do work in pediatrics, they do work in cardiology. It has a high reputation. So they did this study. So there were 6 cases, 6 genuinely tough cases. What they did is, first they asked a doctor or a group of doctors alone to solve it, or to basically diagnose it. Then they gave the doctors the help of AI and asked them to solve it. And after that, they asked AI to solve it alone. So here we have 3 cases. First, a doctor alone is sitting, 6 case studies, 6 medical histories, going through, giving diagnosis. Then we have the doctor who is enhanced or empowered using AI and diagnosing the diseases. And then after that, they also tried AI alone. One of these achieved 90% accuracies, one of these combinations achieved 90% accuracy, whereas the others did not. According to you, which is it? So we'll be doing it in the technical way. Just give me a sec. Okay, let's not just raise of hands. Instead of raise of hands, let's record the observations. So if you have your phones with you right now, just go to the browser and type in menti.com. Just go to the browser and type menti.com, M-E-N-T-I, menti.com. And once you reach that site, just input this code or scan this QR. If you're not able to scan the QR, just enter this code, 63362543. 63362543. Sorry? Yes. Kindly give your opinion in the poll. According to you, which might be the combination that achieved the highest accuracy? Okay, we have 1 vote for doctor plus AI. We have 3 votes for doctor plus AI. Okay, let's wait for more votes. Four votes for doctor plus AI. Okay. Only one combination achieved 90% accuracy, okay? I need more votes. I have these many people here, I need more votes. Only then can I go for an unbiased decision. Bias is one of the biggest curses that we face in data science problems, right? So I need a bigger data set here. So kindly register your polls. Just go to menti.com, MENTI, and just input that code 63362543, and you can give your poll. We only have 4 votes, and that is for doctor plus AI. Yes, guys, nobody else? Nobody else is able to register their poll? Okay, 6 people for doctor plus AI, okay. Again, I want unbiased decisions, come on. I want a larger data set, I want the population to answer. I just don't want a sample. Yes, all done? Okay, 7 votes for doctor plus AI. Anybody else who wants to give an opinion? Okay, 8 people goes for doctor plus AI. Done? Anybody else who's waiting to give their opinion or poll? Doing it? Okay, sure. I want to know. I want to know the answer of the whole population. Only then can I come to an unbiased decision. Otherwise, I'll be driven by data bias. Okay, 9 people going for doctor plus AI. This is going to be a, unanimous win for doctor plus AI. You can do it on your systems as well. And no need of like phones exactly. You can do it on your systems as well. Do we have? Okay, so I hope that's it. Let's come back to our presentation. Okay. So 9 people voted, and all the 9 people voted for doctor plus AI. Now let me show you what actually happened. I hope you are able to read this. This is a bit of a smaller font, but yeah. So the interesting observation, I expected this to happen, to be very frank. That is why I did that poll. So it's scripted, I agree. So the interesting thing that happened is, it was AI alone that achieved 90%. The doctors alone, they achieved around 73%, and doctor plus AI, they achieved 76%. So doctors, when they were enabled with AI, they were only able to make a 3% change, which is not what everybody expected, right? Including me. So the person who wrote this paper or article in JAMA, he himself states that he was astonished. That is the word he used. He was astonished. But there are reasons behind this. This does not clearly state that we are all going to lose our jobs. Let that misconception go away. That is not what is happening here. We are not going anywhere. But there is something deep behind this. That is what we are going to look at. The bottleneck was the interaction. So what happened here is, when the doctors and the AI interacted, the AI disagreed on some things. The AI had different opinions on some things. So then the doctors clung on to their ego. They did not agree with it. And sometimes the doctors interacted with AI where they, knowingly or unknowingly, that God knows, they gave certain misinterpretations in that conversation. That causes something that we all know as hallucinations. So that is why when doctors were empowered with this what to say, very powerful tool called AI was still not able to make the change that we expected them to. But AI alone, unbiased or what to say, uninterrupted, was able to achieve 90% accuracy in the specific problem. But then, coming to the next side of it, in another head-to-head work, GPT-4 gave the best clinical reasoning scores there also. It gave 90% accuracy, but it gave the wrong conclusion. So it is basically like the operation was successful, but the patient is dead. So this is the issue with LLMs. So in terms of what to say, parameters, LLMs do perform good. Because what are they built for? They are built for pattern recognition. That is what LLMs do. They don't understand language like us. They only solve patterns. They only solve puzzles. And that is how they interact. They don't understand the logic behind a language like us. So here, GPT-4, which is a state-of-the-art frontier model, it was able to give very good assumptions, very good diagnosis in terms of writing. But it went to the wrong conclusion. So we have both sides now. One place where doctors are destroying the performance of AI, and another place where AI is seeming successful, but the end result is that the patient is dead. So again, oh, what happened? So now we come back to this fundamental question once again. Where were we? The machine was right, but who is responsible for that? The operation was successful, but the patient died. The AI killed it maybe. Who is responsible for that? This is the fundamental question that we will have to answer. Okay. Now this is the highlight of today's session. So in this session, this is what we are going to discuss about, and this is how we will be establishing the various what to say, failure possibilities as well as the various pillars that will be addressing these possibilities. So this is a chest X-ray. I hope everybody recognizes that. Keep this image in your mind just as it is. Remember the artifacts. Remember what is on the left, what is on the right, and see how it works and see how it is. Keep this image in your mind. It will help you later on. Okay? I hope it has been kept in mind. Okay. So we will be revisiting this image 5 times for 5 different reasons. So that is how this session is going to proceed. So again, this fundamental question is something that we should keep in mind. The machine was right, but who is responsible for it? Okay. So coming to LLMs and VLMs, they perform very well. They score 80% accuracy, they score 90% accuracy, but when they are deployed in the real world, that is not how it goes. So here, a fundamental thing that I'd like to say is, clinical scores or clinical parametrical success is not a guarantee for clinical safety. Let's say we are deploying it in a real environment where, why do we go to hospitals? Because we need to be safe. What happens when the hospital turns hostile? So clinical efficiency or clinical performance or clinical test performance is not a guarantee for clinical safety. This is one thing that I want everyone to keep in mind. So today, there are various things that LLMs are actually used for in hospitals with approval. One is documentation. That is something that we all do. Today, let's say we want to write a report that we have to submit to our boss. What do? Is there anybody here who types it by hand? Please raise your hands. I'll be more than happy to see that. Anybody here who types their report to send it to their boss? Who actually sits and types, thinking about each and every individual sentence one by one? Is there anybody who does that? Please be very frank and raise your hands. No one? No one. Including me. I am included. I am not an exception. ChatGPT. We just give it a random idea, not a random, a vague idea of what we want to express, and it does the, what to say, fluent drafting for us. It will be fantabulous. Of course, we know that. So, documentation is something that each of us uses ChatGPT for. Then coming to the second thing, triage. Triage is something that we see in hospitals. If we have noticed, there is a room called triage. So that is basically another synonym for casualty, where we decide the severeness of the problem. So when we go into triage, what usually happens is there are 3 codes. One is code red, one is code yellow, one is code green, and one is code black. So code red basically means the patient is very severe, needs urgent attention, and he or she should be treated then and there. That is what code red means. Code yellow means it's not that severe, but in the next few minutes to maybe 15 minutes, the patient requires attention. That is what yellow means. When it comes to green, it means, okay, the case is not that severe. Even if we delay it by some time, it works. That is what code green means. Then there is code black. This is something that actually happens in hospitals. Code black means the severity of the issue is beyond our ken. So it is not something that we can address with the facilities that we currently have. So then it is declared code black. So code black basically means give the patient palliative care, the patient is going to die. So this is what code black means. So this is something that AI is actually used for in hospitals today when it comes to US. In India, it is still being implemented because guidelines are being formulated. So this is something that AI is used for. Then coming to the third thing, patient-facing communication. This is something that has been implemented in India because here in India, we have hundreds of different languages. Only 22 official languages, but hundreds of other different languages. So coming to patient communication, let's say, I am going to, let's say, Sikkim, where tribal language is spoken. And to me, it basically sounds like Chinese, right? Nothing else. So I go there and I try to interact with the patient. Is there any use? That is all what happens, right? That is all what happens. So this is the scenario. So here now AI is being used efficiently. So where a machine translation model, simple as that, is being used efficiently so that we are able to transform whatsoever I am speaking real time into whatsoever they understand. So this is something AI is being used for effectively. Conversational diagnosis. So this is something that I recently implemented in my own premises where I've been teaching students. So we conduct mock interviews because in the end, the end goal is to get them placed, right? So we will do mock interviews. So since I'm a lazy guy, I'll admit that. So since I'm a lazy guy, my boss asked me for reports. Again, not willing to type. My fingers hurt. So I don't want to exercise my fingers. So what I did is, I just kept my phone on recording. I informed the student. I kept my phone on recording while the interview was being conducted. After the interview was done, I gave the voice recording to an AI model. So I customized it a bit. I gave it to an AI model, generated the transcript. Once I generated the transcript, I gave the transcript directly to Claude. And Claude generated an HTML report to me with an embedded dashboard. My manager was impressed. He thought that I did a lot of hard work. But I know what happens behind. So this is what LLMs are being used for today. And the final case, knowledge and operations. Of course, that is something that everyone uses it for. So I don't know if you know or not, there is an LLM model called Open Evidence. Has anybody heard of it? No one has heard of it. So Open Evidence is an LLM model. It is a medically fine-tuned LLM model. This is a frontier example in medical LLMs. It has been used by 40% of US doctors for diagnosing their cases. 40% of US doctors have publicly admitted that they have been using Open Evidence to diagnose their diseases. Because medical terms, there are thousands of medical terms. Nobody remembers all of them. If you know doctors, you know how they treat. Because under the table, they do query Previously it was Google search, now it's ChatGPT. That's the only difference. This is something that we have to accept. This happens. So this is of course something that we know LLMs are being used for. But here, yeah, no offense, please. I have not targeted it at anyone. So here we see that we have these LLMs, but in no way are they invasive. No way are they taking critical decisions. These are all supportive infrastructure. This is not critical infrastructure. I hope everybody notices that. Now coming to the main things. Yeah. Now coming to the main thing, main agenda. So Google has recently built something called their AMIE architecture. So which is basically a medical research engine which helps doctors diagnose diseases using input data. So I don't know if like you guys are aware of this. The government of India is working on a unified health database. I hope like people are aware of it. So our data, our consent will of course be taken, that is in line. So once we give consent, our data will be uploaded into an unified database. And once this is uploaded, there are two intentions behind this. One is universality of health data. So let's say today I am getting treated in Hyderabad, and next day let's say I get transferred to Delhi. So when I go there, once we do the registration, we will have to do it again, right? We tell our phone number and we expect, okay, they'll say, hi Joel. Never happens, right? So the first time, let's say you go to Ratnadeep, you give your phone number. They ask you for your phone number, you give the phone number. Second question they ask is, who are you? Or what is your name in a pleasing manner, right? So the literal question is, who are you, right? So this does not happen if we have a unified database. So a doctor in Delhi, let's say, just types Joel Jojo, he gets all my health records. So there is no hassle of carrying that complete handbag of reports anymore. So he or she gets the data instantaneously. That is the, the intention behind it. There is a second intention behind this as well. The second intention behind this is so that we have data about our country that can be used to train our AI. No, I am not talking about SIR here. That is a different scenario altogether. So coming to this unified health database, it is so that our own indigenous models can be trained on real-time data. So the Indian government, so there is a framework that is being designed for this called SAHI or SAHI. So it is basically the infrastructure or the the policies that will govern the use of AI in healthcare in India. So it basically stands for, I have the full form here, so we'll be coming to that. So it is basically a framework for managing healthcare AI in India. So all this is being worked on right now. So that is the reason why this unified database is being created. So coming to this, so some hospital groups are now piloting this in India, where the unified database or data of all our diseases, all the drugs we've been taking. Drugs basically means medicines, okay? Please don't misunderstand me. All the medicines that we've been taking, all the scans that we have done, all these things was once integrated into a specialized database will be used to infer all the risks that we may possess. So recently India is facing a huge rise in youngster deaths because of cardiac issues. So we see, so even in Karnataka recently, a very famous actor, so recently means a few years back, who was very fit. Looking at him, he was very fit. He used to go to the gym daily, suffered cardiac arrest while he was in gym. Look at the irony of that. So there are two reasons why that can happen, but it was mostly because of a cardiac arrest and not because of high exertion. So this is something that many people in India are facing today. We see college students facing this at such a young age. People are dying of cardiac arrest. So when we have such an unified database and we have LLMs integrated into it, now there are multimodal LLMs. So we have VLMs now. We have vision language models which can process multimodal data. It can process images, it can process videos, and it can process text, and it can process tabular data. So all these things are now being combined into a unified system that will basically assist human beings in healthcare 40 to 50%. So all the risk, so if we have to do tests to see if we are developing cancer, if we have a risk of heart attack, or if we have heart related issues, it is not going to be, what to say, cheap, right? So I basically did a few tests for me a few days back. I know how much it, what to say, hurt me. I literally saw money flowing out of my purse. So it's not cheap. We all know that. So once this comes into picture, now we have a promise. It's a promise yet. So now we have a promise that our risks and our diseases could be tracked early. So this is something that LLMs in healthcare can actually give us, and this is a promise that researchers are actually working on. Now going to the next thing, AI isn't a luxury. So now when we discussed it, it might feel like a luxury because let's say I might die of a heart attack. Let it not happen. Let's say I have a risk of heart attack next year, and let's say my AI model is telling me, go to the doctor, exercise, otherwise you're going to die. It's a lifesaver. But to many people in India, AI will not be a luxury. It's a necessity. I was in Delhi at a point of time in my life. I was on an outreach program. I was sent to a village. Okay, life was not easy for me. I do admit that. I was sent to a village. One of my friend's mother, he was also living there. My friend's mother developed an issue, a health issue. Just to get her tests done, I had to travel around 40 kilometers. Just to get normal tests done, I had to travel 40 kilometers to get proper tests done. So AI isn't a luxury for many people, not just in our country, in many places. Even though the US advertises that it is such a developed country, there are places in US that are also remote, which is not something that we people accept, but it is a reality. So for many people, AI isn't a luxury. So in many places in India, even in Kerala, which is a very small state, if you don't know, I come from Kerala. So it is considered to be one of the most, connected states in India. Interconnectivity is considered to be the highest when it comes to Kerala. But even in Kerala, there are some places in a district called Wayanad, where people have to travel around 100 kilometers to see a radiologist in a small state like Kerala. Now think about Maharashtra or Telangana or Andhra. How would the situation be? Think about UP, such a big state. So AI is never a luxury anymore. Now it has become a necessity for many people. Okay. Now coming to what vision language models can do. So now, tell me, how does a radiologist read an X-ray? Does anybody have any sort of medical understanding here? Okay, not expected. So how the radiologist, so let's say we have a chest X-ray, and this is something that I discovered during my research once I made a fatal mistake. Not a fatal mistake, but a very extreme mistake. So how the radiologist actually understands the chest X-ray. So when I was in Delhi, I faced a lung infection. So how do you understand a lung is infected from an X-ray? I understood it that time. So you see a haziness in the X-ray that we take, and that is what radiologists look for. So when they get an X-ray, they point it at a source of light, and what they look for is haziness. So if there is haziness present in the lung somewhere, it means that you are developing an infection. So that is what we look for. So now with the coming of VLMs, we are not doing convolution anymore. I hope everybody is aware what convolution is. We have convolution neural networks where a kernel passes over the image to extract features. Now we have VLMs which look over images just like we do. Now it is able to exactly pinpoint where issues are coming from real time with global understanding, not local understanding anymore. What is the fundamental difference between CNNs and transformers? Can anybody articulate that answer? What is the fundamental difference between CNNs and transformer architectures? Transformer is also a neural network only. Attention is a methodology. Attention, you're right, you're coming to the point. Attention is a methodology, but transformer is also in a way a neural network only. It has a feed-forward neural network inside it. So how can we say transformer is not a neural network? Then what is the fundamental difference between CNNs and transformers? That can be done using RNNs as well, sir. Right, sir? Okay, so coming to the main difference, CNNs understand images through local inferencing. So when the kernels go, it basically takes feature map or local understanding of that image. And once it hits a target, it takes that local understanding to, so what actually happens is the kernel is walking over the image, right? So when it hits a hits a treasure or it hits a hint, it basically sends a signal or it basically raises the tally a bit. And every time it hits a signal, this tally increases, and that is how it finally comes to the output. So CNNs, come to the output through local inferencing, or they understand images bit by bit locally. When it comes to attention mechanism, it's not a kernel moving anymore. The whole image is understood globally now. So the context is developed keeping in mind the broader context in mind. So that is the sole difference between convolutional neural networks and transformer architecture. So now when VLMs have come into the picture, now they are able to understand these medical data sets just like we humans do. They are able to properly infer, yes, here there is an issue or here there is an issue, keeping in mind the complete picture. So that is why they have become so effective. And now we have multimodal architectures as well, which can literally read and understand data just like we humans do. What do doctors do? They have reports, they have medicine reports, they have scans, maybe they have x-rays. They keep all in mind and then come to a diagnosis. So I've heard from some of my friends that doctors usually use three things to, come to a conclusion if the person has the issue or not. First thing is symptoms. Then the second thing is tests. And the third thing is any scans or any invasive mechanisms. So if any of these two turn out to be a proper indicator or indicates that a person has a certain issue, they go for it. They go for treatment. So there are some diseases for which treatment is also costly. Not costly in terms of money, costly in terms of health as well. One of the best examples is cancer. Let's say we don't have cancer, we go for chemotherapy, what happens? We die because of that, we die because of radiation exposure. So there are some places where diagnosis is costly. So it is an important decision for doctors, and it's a risky decision for them as well, because medical negligence is not taken lightly, especially in India. So now we have these multi-models which can do the same thing and come to the decision same like a doctor would do. So now it has a perfect companion. Now doctors have a perfect companion, and it has been reported that through studies that reporting time has lessened by 40 to 50% once AI was introduced with doctors, or AI was introduced to assist doctors. 50% reduction, which means that if you had to wait for 3 hours yesterday, today you only have to wait for 1.5 hours. That's a huge difference in terms of a large population. So this is what AI seems to promise us, and now the AI is able to analyze images just like how an expert would. That is what AI is promising us at least. Now, coming to the thing. Any two tests of the three, we go for diagnosis. Let's say it goes wrong. What do? We sue the doctor, right? We go behind the doctor. He or she is not going to have a good time, right? But if it's AI, what do? We'll go to the hospital. Okay. So let's say, it is being used in many hospitals, or all over India the same model is being used. Then what do? Try going to sue the Indian government maybe, right? So this is the fundamental issue that we face when it comes to AI in healthcare. Who is responsible for it? So coming to who is responsible for it, before that, we have to understand where AI might fail. So where this accountability might come. Coming to that, the first thing, confidently false. This is one of the biggest risks that we face with respect to LLMs. LLMs have something or face a certain issue called hallucinations, right? So what this test did was a group of medical experts, they created case studies, and in every case study, they made a very small mistake. In every case study, they, knowingly made a very small, rare mistake. Keep all these terms in mind, very small, rare mistake. What happened after that is all the LLMs achieved 50 to 82% hallucinations. So the fundamental issue with LLMs is that they are people pleasers. LLMs are people pleasers. They are meant to please you. So let's say you say something rubbish to, let's say, Claude, GPT, Gemini, or whatsoever, Grok, whatsoever LLM model you use, say something rubbish to it. Has it ever given that back to you? Let's say you even call it names. Does it ever say it back? This is the exact problem with LLMs. They are fundamentally trained to please us. So when the doctors gave the interpretation that such and such a thing is wrong with such and such a person, it created a whole medical theory out of it. So let's say I went to a certain place and I say my right knee is facing a certain pain in the morning. I think I have brain tumor. And the AI says, yes, that is a likely scenario. Most probably a nerve in your knee is connected to your brain, and because of your tumor, you are facing the pain in your knee. It created a whole medical theory at the very instant. But is it true? No, it is not true. So, such small mistakes led to 50 to 82% hallucinations in LLMs. Who is responsible for it? Or who, guardrails this? So this is a fundamental problem that we face when it comes to LLMs. Okay. Now the problem comes to us. Let's say we don't know about something. Let's say today, or somebody just came today, or let's consider we are all students for a day, okay? The professor came to the class and just said, give me an assignment of 10 pages on the transformer architecture by tomorrow. We don't know anything about transformer architecture, and neither do we care to read about it. What do? We need to give it by tomorrow. Let's say we have weekend plans today. Today is Friday evening, tomorrow is Saturday, we have something planned. But the professor is insistent that he or she needs the assignment tomorrow itself. What do? You go to ChatGPT, we type in, I want an assignment on transformer architecture with images and with the derivations in 10 pages. Whatsoever rubbish it gives us, will we ever question it? No. Why? Why? Don't tell me because it's ChatGPT. Why? I'm asking for the fundamental reason behind it. Sorry? We don't know, that is a fundamental reason, of course. But why do we trust GPT so much? Sorry? Okay, when GPT came out in 2022, everybody was using it just like, it was God. Why? Then they did not know about who trained it, what trained it, where it came from, nothing. It was something new to us. It was a new toy that we got. But why? That's my question. Yes, that's the exact answer. We have set in our minds that it is very trustworthy. But why? It's giving answer to every question. How? How do we know it's accurate when we ourselves don't know the answer? Okay. I'll give a scenario. How do you know? Oh, known questions. But let's say, okay, coming to a person like me, you ask me everything about convolution, I tell answers. Does it guarantee that I'll know transformers? Then aren't we the fools? Okay, we'll come to a real life scenario. This is something that we all do, but I'm just reminding you. Let's say we are going for an exam, a Viva, okay? We've learned nothing, absolutely nothing. Then what do? We call a friend or somebody who's available in the morning, mug up the summary as much as possible from that person and go and sit for the Viva. Let's say we don't know anything. We want to somehow clear the interview. In college, let's leave companies aside, in college, what do? Use flamboyant English. Use words like decimated, deciphering, flossinociny, hilifilification, all these words. You are more likely to clear that interview. I'm telling you. This is something we do in companies. Sometimes, this is something that I myself have noticed. Sometimes when I sit for interviews, even research interviews, let's say I don't know the answer to one question. I beat around the bush and I know this is being recorded, but I'll admit this. I beat around the bush in such flamboyant English that the interviewer finally says, okay, good. I myself don't know what I've said. This is the exact reason why we trust ChatGPT. Because it gives answers with such flamboyant flow that we somehow go ahead and trust it. Sometimes, especially when I've been in North India, I'm not being discriminative here, but this is something that happens more in North India. We interact a lot in North India. In South India, people talk less, but in North India, people talk a lot. So sometimes a new Chachaji or somebody comes, he talks a lot in very good language. And my, auntie or someone calls me, see how knowledgeable that person is, go and sit there, learn something from him. But he's talking about AI. I am myself an AI trained professional. And he is coming and telling me, see how well he's speaking. He knows a lot about AI. Go and learn something from him. I say, acha, okay. And I go and sit there, and I'm not, this is just for illustration purposes, no offense. The guy is telling, AI is such a wondrous object today. How we train AI is actually, we show it images and videos, and we shoot it with a camera, and there is a computer behind it that learns using AI. And Andy said, this guy is not more knowledgeable than me. So you see the irony. Just because somebody is able to frame whatsoever answer is in a very good manner, we go ahead and start trusting the person. This is what we call automation bias in AI. We have, just like Sir said, we have sort of developed that feeling inside us that GPT is more trustworthy than anybody in the world today. And just because of that, I know I have no issue. I exercise every day. I have no issues whatsoever. I am able to run at, let's say, 10 kilometers, 12 kilometers per hour for, let's say, 100 meters, 200 meters. I Google, I type in some symptoms into ChatGPT, and it tells me that I have heart issue or I have risk of heart attack. I'm asking you guys, if this happens with you, will you not run to the hospital the next day? Or at least in a week? Of course, right? So this is the exact issue when it comes to AI and doctors. So we have something called automation bias. So let's say we have this issue. What if doctors have this issue? We have this issue. Think about a day when doctors have this issue. It's actually there. This is not hypothetical. What happens when doctors develop this issue? GPT says, okay, this person looks like he or she might have cancer. Okay, start chemotherapy. And the person dies of radiation exposure. So this is a what to say, a very imminent risk that is present with AI. So the first thing that we discussed about, so let me come to the first slide, is hallucination. The second risk that we discussed about is automation bias. Now coming to the third. So in the US, I don't know how many of you here are aware of this. So in the US and in the Europe, it's prominently, or previously it was prominently Christian. So in Christians, there is a ritual. It's not a ritual, it is basically something that is done. It's kind of like a custom. So when we come to a notion that a person is about to die, or it's almost a 99% guaranteed that this person, the time has come for this person, we call in a priest and pray for the certain person. So now consider a data set is made out of this, okay? So a data set is made out of this for people in ICU. Consider that tabular structure. I'm asking you to imagine it, okay? So we have heart rate, let's say mobility, we have many independent features like this. And let's say we have one feature called priest visit, okay? And the target variable is that will the person die or not. You will see that every time a person dies, priest visit equal to 1, not 0. Why? Because when we know the person is about to die, we call the priest anyway. But see the data set. Death 1, 1, 1, 1, 1. Priest visit 1, 1, 1, 1, 1. So what is the correlation value? It's 1. So whenever a priest visits, the person will die. So let's say I have a friend who is a priest and I just had cold and cough. Let's say I developed pneumonia and they took me to the ICU. And there is an AI model there who is assessing whether I'll die or not. So let's say I have a friend who's a priest who just came to visit me to see if I am doing well or not. The AI model will ring the siren. This person is going to die. Why? The priest is my friend. He did not come to kill me. So this is one issue that we face with LLMs all around the world, something called shortcut learning. So one thing that was noticed when people were learning about how LLMs interpret chest X-rays and associate it with terminal illness. So how likely is that the person is likely to suffer a fatal issue? When it came to that, when we took up explainable values like SHAP, Lyme values and all, we came to the understanding that when portable scanners are used, X-ray usually comes in a different manner. Usually, when we take a chest X-ray, do they make us lie or do they make us stand? Has anybody taken a chest X-ray here? Many times, right? So do they make us lie down or do they make us stand? They make us stand, right? They make us stand like this and they take the X-ray, right? But what if the person is terminally or seriously ill? Can the person come and stand like this? No. So most likely the person is bedridden. So for that person, we will have to use a portable X-ray scanner. So what the AI model did is, there is a certain orientation which was common to portable X-ray scanners. So the AI model identified if the portable scanner was being used and then used that to decide if the person was in risk or not. But is it actually true? No. It is just analyzing if a person is standing or lying down. What does it have to do with I'm terminally ill or not? Nothing, right? So this is one serious issue when it comes to LLMs. It uses something called shortcut learning. And this was something that we experienced during COVID as well. So in COVID, there was a huge rush to hospitals. We had a proper pandemic. Resources were scarce. Everybody was running for treatment. So at that time, a lot of AI models were rolled out, telling that this will help diagnose if the person has COVID or not. So antigen test, all those tests, it took a bit of time to come out, right? And AI models were able to come with results in seconds. So in many places, it was actually used. But it was only after COVID, when all these results were analyzed, that people found these AI models were actually taking into account which hospital that X-ray was from, to decide if the person had COVID or not, or which region the person was from. So in some places, so let's say in Hyderabad, there is Nilafar hospital, and let's say there is Apollo somewhere. So X-rays taken in Nilafar hospital might be using a certain machine of certain company, and it might look in a certain way. And in Apollo, it might be a different machine, and it might look a certain different way. Because with respect to machines, the markings and all come at different places. So let's come back. Where was it? See this? See this? So when the X-ray is of the right side, or when the X-ray is of left side, we have indicators in the X-ray that do so. So let's say we have a scan of our elbow. When you give it to the doctor, how does he or she know if it is left or right? So let's say our left elbow was broken and we put plaster on the right. Has happened, right? So how does the doctor identify if it is left or right? We have these indicators. So the position of these indicators differ with respect to different companies. So during COVID, the AI model was understanding or using its kernel to see the presence of these indicators to understand which company the X-ray was of, to ascertain which hospital or region the X-ray was from, to tell if a person has COVID or not. How misleading. So this is one imminent issue with LLMs, which is called shortcut learning. We're talking about shortcut learning. Then coming to something that we all know, which is something called distribution shift and bias. So if our students or we have ever tried implementing ML-based algorithms to actual data sets or actual problems in our country, we have all faced this. Because most of the data sets available in Kaggle are US or Europe based. Dataset deficiency is a real problem with AI in India. It's not a small problem, it's a real big problem with AI in India. Because most of the datasets that are available to us, let's take UCI, let's take Kaggle, let's say whatsoever ML repository that we are looking into, it's mostly US or Europe based. No Asia, no Africa. So let's say we take these US and Europe datasets, train a model on it, and test it on Indian people. Will it ever work? So if a model was validated in Boston in US, and if it is used in Warangal in India, it is never going to work. Because our features, their features are totally different. So let's say we are checking for melatonin, skin cancer. So I'm not being racist here, but in the skin of white people, it is more likely to be visible. Whereas we people who are comparatively more tanned, it is difficult to notice if it is in the first stages. So this is an issue that is ever present in the field of machine learning, and this is something that haunts LLM as well. So these are the things that we should actually address when it comes to LLMs in healthcare. Everybody is talking about the hype of LLMs. We are using open evidence to diagnose diseases. We are using VLMs to, do case studies. We are using, all these different multi-models to come to diagnostic diseases, to decide which patient is at what risk. But have we ever thought about all this? So at first, when I was actually thinking about taking this session, in the beginning I thought about all these different examples about LLMs in healthcare. I thought about all these different use cases, and I was into the hype. But then what actually happened is I came across an article which was talking about all these risks in healthcare when it comes to AI. I was just reading by, and then I understood, or I thought, my research is itself on responsible AI, and how can I be so irresponsible? And then I came to the heading or a topic of this workshop, which is explainable and responsible AI. And that is when I got this direction. And that is how I changed my complete presentation, and I came up to this. Then, this is where, I believe, did I miss a slide? No. Okay. So this is where we are now facing a trade-off. Just like we have the bias variance trade-off when it comes to machine learning, Now here also, we have a trade-off between our conscience and AI's conscience. Does AI have a conscience? It's a question mark, but still, based on our decision and AI's decision. The thing is that AI has beat physicians in many tests. In many clinical tests, AI has outperformed physicians. Let's say we make AI write the NEET exam, it will score 100 out of 100, whereas no human has done so. Let's say we make AI write the JEE advanced exam. Can anybody here tell me they are confident that if they prepare for, let's say I give you 5 years, 5 years with, food and money. Let's say I give you that offer. And within 5 years, how many people can assure me that they will be able to score 100 out of 100 in JEE advanced? Will there be any person who can assure me that? No. Because for one thing, the questions that come in that exam comes out of some world. I don't know, sometimes the professors who prepare those questions seem to be so ambitious that sometimes even questions don't make sense. When I wrote that exam, JEE mains was okay. But when I went for advanced, questions were like, I was questioning myself that what is this guy trying to tell me? I was not able to understand the question at a point of time. So, there is no one who can guarantee that they will be able to score 100 out of 100 in JEE advanced. But AI did. That is one case study. Then the second case study is that in a scenario where a person actually had heart disease and somewhere, in the diagnosis or diagnostic report, the doctor accidentally forgot to tell that the pain was on the left side rather than the right side. This happens. This is something that happens in medical colleges. My friend, while he was doing his house surgery, he told me that one of his seniors accidentally committed this mistake. So he got the X-ray of the right side. So house surgery is not easy. 36-hour shifts. You are half asleep. Got an X-ray. He did not see the notation. So instead of right, he thought left. He plastered the whole left hand and left the patient. He had to deal with severe consequences after that, of course, but this is something that actually happened. So this sometimes happens when we diagnose with AI as well. AI is told that the patient claims that he or she has a pain on the right side. Will it ever suspect a heart disease? Because when it is respect to the heart, the pain is usually on the left. So will it ever tell us you are at risk of heart disease? It will hallucinate. It will say this pain might be because of some head juice falling off, or you might have sprained the hand or something like that. It will develop theories of his own. So the patient went to get his heart disease cured, and in the end he got a paracetamol. So this is the trade-off that we face when it comes to implementing AI in healthcare. Okay. Now coming to the most important discussion, which are the 4 pillars that we have to keep in mind when we talk about effective AI in healthcare. So let me just keep track of the time as well. Okay, it's only 3:30. Okay, we do have time. Okay, so before we start off this session, we'll take a break of let's say 5 to 10 minutes, and then we'll go ahead and discuss about the 4 various pillars that will help us address all these problems that we've talked about currently with respect to AI in healthcare. So I hope everybody is a bit refreshed and we can restart the session. So previously we were talking about the different failures that are possible when we use LLMs in healthcare. Not just LLMs, let us just generalize it to AI in healthcare. So we were talking about the issue of hallucination, we were talking about automation bias, we were talking about shortcut learning, and we were also talking about distribution shift. So now we have talked about failure possibilities or the cause of failures. Now the billion-dollar question is, of course, how to cure it or how to address these, right? So the first thing that, of course, that we can use when it comes to ascertaining the decisions that we are taking is explainable AI. So we have all these different what to say metrics that we use in explainable AI. We have SHAP values, we have line features, we have all these different metrics that help us understand how an LLM or how an AI model is finally coming into a result. So we have all these salient maps. So believe I have it on the next slide. What we've been discussing, so which are the solutions to all the 4 failure opportunities that we discussed with respect to AI in healthcare. So the first way, of course, that we discussed about is using explainable AI. So in explainable AI, we have these saliency maps which actually shows us which region of the image that AI focused, so that we are able to understand on what basis a certain decision has been taken. So explainable AI is one of the best solutions that we can have with respect to, so in the first slide we were discussing about which pillar would be addressing which failure opportunity when it comes to LLMs in healthcare. So explainable AI is a direct answer to shortcut learning. So in shortcut learning we were discussing about AI identifying artifacts in the image to judge what is going on inside the image. So if we are analyzing if pneumonia is present in a specific X-ray, the model is trying to ascertain which hospital or which sort of scanner the X-ray is taken from to come to the decision of whether a person has pneumonia or not, which is a wrong judgment. So it is basically judging on the basis of region that a person has come from to ascertain if a person has pneumonia or not. So explainable AI helps us recognize if the model has focused on any specific artifact or notation, or if it has actually focused on the X-ray. So this becomes a direct answer to shortcut learning as well as automation bias, because now we don't trust AI blindly. We are able to understand on what basis AI has taken a certain decision. So now just because of flamboyant language we don't come to a decision. Instead, proof is kept in front of us to basically ascertain why AI has come to a decision. So that helps us take much better informed decisions compared to earlier. So that is how we come to what to say, a solution in terms of shortcut learning as well as automation bias. But there is one issue with explainable AI, that the saliency maps are also prone to adversarial attacks. So if someone or the other manages to tamper with the code, they can basically put a layer on top of the saliency map such that it gives us a wrong interpretation but another conclusion. So this is also one thing that we have to keep in mind when it comes to explainable AI. Okay, so now coming around AI safety. So AI safety addresses 2 issues, which is basically hallucination and distribution drift. So coming to AI safety, one of the methods that can be implemented with respect to LLMs in healthcare is of course integrating it with a RAG pipeline. So let's say recently a certain change has come with respect to standard operating procedures in the medical field, and the LLM has been trained maybe 2 months ago. So now when it comes to a certain conclusion or certain diagnosis for a certain disease, now it basically takes decisions based on pre-informed what to say notion that it had. So maybe at that time a certain drug might have been considered effective for, let's say, cancer, and maybe 2 months back or 2 months later it might have been proved that that specific drug is actually harmful to the person. So when it comes to the next what to say, the 3rd month where AI is making an information or making an informed decision and deciding a certain drug should be given to a certain patient, it considers its training data which was maybe 4 months back. So this is a very big issue that AI faces with respect to hallucination. So the way we can solve it is basically by implementing a RAG pipeline, which is a database or a vector database, which would contain the latest information that is always updated. So this helps us what to say, address the issue of hallucination and also distribution shift. So if we have our vector database embedded with data that addresses the specific population that we are targeting on, so that will help address the distribution shift that we are facing with respect to AI models as well. Because all these models are trained mostly on US or European data. So when it comes to Indian or let's say African based scenarios, we face a huge issue where what to say, the test set is inherently different compared to what it is trained on. So here when we use pipelines like RAG, where we have a database which is catered to us. So previously we were talking about a unified health database in our country, which would actually form the basis for this RAG pipeline, where we will have diagnosis of actual Indian patients inside that data. So when we implement that RAG pipeline with respect to the LLM that we are implementing in our country, that helps us deal with the distribution shift in a great manner. Then another thing that we can do is uncertainty quantification. So when the LLM gives us a certain decision or a certain, what to say, diagnosis, it can associate a score with it. So it can say how confident it is. So when we used to deal with normal machine learning algorithms, of course we used to, what to say, attach a confidence score along with it. So if, what to say, a certain machine learning model is saying malignant or a certain tissue is malignant, it will attach maybe 91% or whatsoever is the confidence score that it has with it. So that helps us take much more informed decisions compared to LLMs, which give a flamboyant English sentence in very good, what to say, using, what to say, very, what to say, if we say in Hindi, Bari Barkam Hindi, English words, along with, what to say, flamboyant English grammar. So we go ahead and trust it without any proof. So attaching an uncertainty score along with whatsoever an LLM says helps us quantify this. Then it comes to the importance of system prompt. So whenever we design a GenAI workflow, we have many different kinds of prompts in it. So when we talk about, what to say, the prompt that we give the LLM, it is called the user prompt. But inherently inside the workflow, we can tune the LLM based on the system prompt. So it is instructions given to the LLM based on the workflow that it is supposed to implement. So every time a user prompts the LLM, it will first run the system prompt, which is basically a training mechanism that tells the LLM the constraints in which it should function. So one of the things that, what to say, matters when it comes to an LLM is first the objective, then the description, and then the constraints. So all these things are basically decided in the system prompt. So how well a system prompt is written in a generative AI workflow is what matters, or is what is the deciding factor between a model, whether it would hallucinate, or whether it will be prone to shortcut learning, or whether it will be prone to automation bias, or whether it will be prone to distribution shift. Then we have something called middleware when it comes to generative AI workflows, where we insert it in between the workflow of an LLM model. When it comes to an important decision, it stops, pauses, takes a moment, asks for human validation, and with respect to our decision, it executes the next step. So now a methodology called human in the loop middleware has been implemented in generative AI workflows so that important decisions can be taken with human sign off. So the human becomes accountable for the decision that the LLM is taking now. So we started with the question in the beginning, the machine was right, but who is responsible for it? So now somebody has to take accountability when it comes to the LLM model. That is why we have middleware now. Now coming to responsible AI and governance, this is something that, what to say, very few are talking about right now, but which is something that everybody should talk about. So when we were discussing about the California wildfires that happened in the US, they did not have water to extinguish it because data centers were consuming all the water that was available. So this is where the concept of responsible AI starts gaining importance, because we have to use AI in such a way that we are actually benefiting humanity rather than making it a bane. So here, when it comes to India, India has now implemented various, policies with respect to implementing LLMs in healthcare. So ICMR has given a very famous sentence, which has become very famous right now. So AI cannot be held accountable for its decisions. So we need some way by which we can explicit human accountability inside this framework. So this is exactly how middleware works. And this sentence is now being quoted in many different conferences, so that, in many different conferences, this quote by ICMR is now being taken as one of the forefronts when it comes to responsible AI in healthcare. So the machine is right, but who is responsible for it in the end? Let's say the machine makes a right decision that led to the wrong outcome. So basically the operation was successful, but the patient is dead. So who is responsible for it? So in India, ICMR is now coming with this SAHI strategy, which is basically secure implementation of AI in healthcare in India. So this framework is being developed, which contains test cases, which contain validation policies, and which contain frameworks or methodologies by which real high-end medical institutes in our country can actually validate the model before it is launched in public. So India is working on this strategy under the Ayushman Bharat digital mission, which is now becoming the backbone of the unified health database. So India is working a lot to developing a proper working governance policy, just like we have the AI Act that is happening in Europe. India is now developing a policy so that we can actually implement AI in a much larger scale. So coming to US, now US has developed this, Food and Drugs Regulatory Authority of the US has developed this SAMD pathway by which, every model is now posed to 4 different stages of assessment. So just like when we launch a drug, so while it was COVID, we actually became aware of the rigorous testing process that goes on before releasing a drug. So before Covishield was released, it had undergone 3 levels of clinical trials. So first it is done on a very small sample or population inside a clinic, then it is rolled out to a much larger public, and it is then rolled out to a wider variety of population, not just one. So maybe it was first manufactured in Serum Institute in India, then it is not just tested on Indians. One sample is that of India. Samples are sent to US, samples are sent to Europe, samples are sent to Africa. It is only after all these clinical trials are completed that the medicine can actually be launched. Now the same framework is applied to AI methodologies or AI workflows as well, where it will be tested on the basis of hallucination, it will be tested on the basis of automation bias, not just flamboyant language, but relevant proof behind it. It would be tested on the basis of shortcut learning, if it is actually analyzing the image or just analyzing some artifacts which give it hints to come to a conclusion. Or finally, in the end, is it suffering from distribution shift? So that's a deployment issue, and that can only be ascertained once we roll it out to a larger population. And of course, the European AI Act has now become so stringent that AI development itself is facing a huge struggle. So now the the formalities or the red tape, it's a bit of a red tape itself, I'll have to use that term, that has come around AI in Europe is actually restraining AI development to a certain extent. So Europe is of the opinion that it is better AI doesn't develop if it is not responsible. So what happens if Mythos 5, which is now a model developed by Claude, goes out of hand? So it is a model which is claimed to be jailbreaking into even the most advanced cybersecurity systems. So that is why the US Department of Defense has now restricted its export altogether. Fable 5 was banned internationally. It was only restricted to citizens who are Americans by birth, not even foreign nationals who gained citizen by naturalization. So that is how seriously countries are taking AI policy now. And this is how AI governance is gaining importance now. So it's much more important that we become aware of this today. Then coming to another very important problem, which is efficient AI. So previously we were discussing that for many remote places in India, AI is no longer a luxury. So for people who have to travel 100 kilometers to see or get an X-ray done, an AI model that will be able to analyze their X-ray from a portable scanner and tell if they should take the pain to go and visit a proper doctor 100 kilometers away would be a lifesaver for them. Not in terms of money, in terms of money, effort, and living. So this is where efficient AI comes into the picture. So now there are many techniques when it comes to making AI efficient, like depth-wise separable convolutions, quantization, distillation. These are techniques which need to be discussed much more commonly rather than just LLMs and generative AI. So recently, ChatGPT was complaining a lot about Claude, telling that Claude is basically taking information or inference from ChatGPT to train its models. So this was an accusation which was made by Sam Altman. So what actually happens in such scenarios is that ChatGPT models, if such thing happened, I'm not claiming such things happened, I don't want to be sued. So let's say Claude is training from ChatGPT. ChatGPT is taken as the teacher model and Claude is taken as the student model. And in between them, a distillation workflow is decided. So what it basically does is, in every hidden layer, while the logits are being produced, a loss function is calculated in every hidden layer. That is how basically the student model tries to mimic the teacher model, and this is exactly how distillation works. But the actual use of distillation comes in efficient AI, where we can train much smaller models compared to larger models, which can have the same performance as those larger models. So let's say we are taking ResNet 50 as the teacher model, which has 50 million parameters, and let's say we are taking MobileNet or EfficientNet, which has much less parameters, let's say 10 million or something, and we are training the EfficientNet from the ResNet using distillation. So in the end, we will have a 10 million model which has almost the same capabilities as ResNet. So that is when AI can actually be implemented on maybe, let's say, edge devices, although not edge, let's say at least personal computers, so that even in village PHCs, people can upload an X-ray into the system and locally infer if a person has a risk or not. So this becomes a lifesaver for many people, and that is exactly how I believe AI should be used responsibly. So right now, many efforts have been made to making LLMs much more accessible. So in terms of healthcare, Google has developed a model, so Gemma or Gemma. Gemma is an open source LLM that is made available by Google. So now they have created a medically fine-tuned version of it called MedGemma. And this MedGemma is available as a 27 billion model and also as a 4 billion model. So they have basically used this 27 billion model, and after that they created a 4 billion architecture which was trained using distillation from the 27 billion model to create a model which could run in our systems today, which is exactly what we are discussing in our hands-on session today as well. And Meditron is the same effort from Meta, and we also have Tiny Lava Med, which is a multi-model architecture which is promised to run on NVIDIA Jetson Nano. So at least PHCs which can infer maybe invest maybe 1 or 2 lakhs can now have multi-model architectures doing inference, which when uploaded, let's say scans, X-rays and a bit of diagnosis, can tell what could be the cause of so and so, what disease he or she is likely to have, and which doctor he or she should go and consult in which hospital. So now a multimodal network is able to run on a small computer just like a doctor with hands and legs would be able to do. So when we do video consultation, we just have a doctor talking in the screen. Now it's like we have a virtual entity standing in front of us. And once agentic capabilities are introduced into it, we even have a system that can go or book an appointment for us. So now all this becomes an entity rather than just software. So in India, a lot of efforts have been made towards democratizing AI. So Vadhvani AI, I've had the opportunity to interact with the stakeholders in Vadhvani AI at a point of time. They are actually doing quite impressive work with respect to healthcare at remote locations. So one of the biggest issues that especially North India faces is with respect to child mortality rate. So compared to South Indian states, in North India, because the population is high and also resources are bit slim, child mortality rate is pretty high. So what Vadhvani AI did is, if an ASHA worker is able to click a photo of a child, from that photo, the AI model, which is basically a deep learning network, not any advanced architecture, would assess the weight of the child and classify it in a high risk or low risk scenario based on the weight itself. And because of that, they piloted it in 2 villages. They were able to bring down the infant mortality rate by 40%, which is almost half. Then another big, achievement that Vadhvani AI made in terms of TB. TB is a disease that has been haunting India since quite a while. So they developed an architecture which would identify if I have a disease of getting TB from my cough. So if I have a smartphone and I record my voice of how I cough in my smartphone, an AI model which is basically deployed in cloud will analyze that audio recording and tell me if I have a chance of getting TB or not, or if I have TB or not, based on a confidence score. So on the basis of that, I can get diagnosed much more faster compared to actually waiting so that I can get a consultation from a good doctor. So Vadhvani AI is something that I know personally, which is why I touched upon it myself. Nirmay Thermalytics has been doing great work in terms of recognizing lung-based diseases, as well as for women they have many reproductive system based diseases which require mammography to be identified. But but the issue with mammography is that this is not something that we can do on a regular basis because we have radiation exposure. So what Nirmal Thermalytics did is that they used high-end thermal imaging to basically identify diseases from heat maps. So with that, they solved the problem of radiation exposure, and now we have a system by which we can get regular checkups done. So these are the things which are happening in India. And of course, eSanjeevani is a platform which the government of India is currently running so that we can have teleconsultations, and the consultations, the rise of consultations from 2023 to 2025 is around 282 million. So people are willing to use technology for their benefit, just that we have to enable them. Then coming to futures, of course, we discussed all this. If we actually add agentic capabilities to these LLMs that are already diagnosing, now it can go ahead and book medicines for us, book appointments for us, and actually act on our behalf. If a reputed person or an accountable person like a doctor is signing it off in terms of middleware. We have multimodal models which can analyze X-rays, CT scans, and diagnostic reports together. And once we implement efficient AI, we will be able to get it on edge devices everywhere. So finally, we come back to the first question that we discussed in the beginning. The machine was right, but who is responsible for it? So implementing AI and making it more accurate is of course an interesting task, and it is of course welcome. But in the end, the main question when it comes to healthcare, a 9 Sigma portfolio, is who is responsible for it. And I believe these are the questions which need more answering than just applications in healthcare. So with that, we come to the end of our session. So we need to understand what AI does well and what it does not. AI does high volume pattern recognition, which is basically what all LLMs are. But when it comes to rare cases, when it has distribution bias and all these things, AI suffers. So we should know what AI does good and where AI suffers. And this is how we should go ahead and implement it. So with that, we have come to the end of the session. I thank you all for being here. Thank you.